In this particular video, we're going to look at Unit 4 Physics, IAL, Edexcel. So this is the concept of capacitance. We're going to see how you're supposed to approach different questions that have been asked in previous years. And then we get to see how do you maximize the marks and how do you maximize the approach in order to attain that particular mark that you want to attain. So if you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. And also, if you are not joined our Patreon page, consider checking the description so that you can be able to access the PDF of these papers that I'm sharing at this given point. Without much ado, I would like to take you straight so that we can be able to have a discussion on what is expected in this particular tutorial. So here we are told that a student builds the circuit shown. The capacitor was initially uncharged, and then we can be able to see it's connected in such a way that is series with the rest. We have the source of PD, and then we have the capacitor at this given point. And then we are supposed to answer a question. Then she closed the switch and plotted a graph of current on the ammeter A1 against time. So what are we supposed to do in order to determine the initial value of the current? We are told that determine whether the initial value of the current of the graph is consistent with the value on the diagram. So in this particular part, you realize that we are going to use the formula current is equals to V over R, whereby V is the voltage, which is 0.5, and then the resistance that we are having here is 33 kilo ohms. So which means that at that point of time, we are supposed to ideally try to work out so that we can be able to check the value. If you use the values that we are having on the graph, is it going to be an equivalent to the value that is showed on the graph here, right? So if you do the calculation, you're going to get this is going to be 0.15 milliamperes. And if you look at the graph, you can see the value that is indicated there is 0.15 milliamperes. So meaning that this value that we have, the initial value of the current on the graph, is consistent to the value stated on the circuit diagram. We are supposed to explain how the current in ammeter 2 will vary over time. Explain how the current on ammeter 2 will vary over the same time. So we are going to realize that since this is a series current circuit, we shall say that current will vary with time in the same way as ammeter 1, because all these ammeter 1 and ammeter 2 are in the series circuit. So they are going to vary the same way because current is the same everywhere in the series circuit. Next part is where candidates are expected to determine the capacitance of the capacitor. And in order for you to determine the capacitance of the capacitor, in this case, you can be able to identify a point whereby you can be able to read the current and the corresponding time for that. And for that case, you can see here, I identified this particular point that is here. I identified this point. So I read the current, this point, and also I read the time down there. And those two values, I used them in the formula ln of I is equal to ln of the initial current, which was this current here. And then when I substituted here, I was able to work out the value of C, because capacitance is C, and the time already we have it as 3 seconds, and then we have the resistance, which is well stated here. So if you work it out, you are going to get the capacitance to be 2.24 times 10 raised to the power negative 4 farads. We are supposed also to determine the charge stored in the capacitor in the 30 seconds. So what you are supposed to remember is that charge is equals to capacitance times voltage, and in that case our capacitance, we have gotten it here. So we are supposed now to use the voltage that we are having at this point in order to work it out, and you'll get it to be equivalent to 1.1 times 10 raised to the power negative 3 coulombs. If you are asked to determine the maximum energy stored, you need to remember that energy stored is the same as the work done. Energy stored can be given by the formula a half QV, charge times voltage. It can be given as a half capacitance times voltage squared, or you can also work it using the formula a half Q squared C. So those are the possible formulas that you have in your disposal in order to work out that capacitance in that case, the energy stored, maximum energy stored. And then we shall have it in mind that we are going to use the concept of W is equal, or the work done or the charge stored is maximum charge stored is going to be equals to a half CV squared. So in this case, I used the concept of which formula did I use here? I used the formula charge is equals to a half QV. So charge already, we have it in this part, and then I multiplied the voltage in order to get the maximum charge stored. I would like also to bring to your attention that in the event you are asked to work out the charge stored in the capacitor 30 seconds, you are going to work out the area under the graph. You shall focus on working out the area. In order to find alternatively the charge stored, whenever you have a question like this, you can be able to work out the area under this graph. So if you manage to work out the area under this graph, you'll be able to work out the amount of charge stored. So those are a few things that you must master in order to maximize in this particular paper 4. A student investigates that. So moving to the next question here, we are told that so we are told a student investigated the charging capacitance. She measured the current in the capacitor circuit as shown there. Add the diagram to show the suitable circuit for measuring the current and the capacitor charged. So basically that is another set of questions that we need to look at, and the part that was given here is this section that we have here. There was a resistor and there was a capacitor. So in order for us to measure the current, we are going to have a cell which is going to act as a source of PD, and then we shall have our ammeter in series. So and the resistor, then we're done like that. The resistance of the resistor is 5.1 kilo ohms. We're supposed to show that the capacitance of the capacitor is about 0.0 microfarads. And in this case, we are going to just identify a point on the graph. You measure the corresponding time, and on the other side, you are going to measure the corresponding current. So in that way, we are going to use this particular equation. And remember, whenever you are having this equation like this, you can be able to introduce logarithm so that you can be able to remove the exponent from this particular part. Remember, the purpose is to find the capacitance, and the capacitance is the value of C that we are having here. So if you are going to introduce natural logs here, you have ln of I current, that is the current that is remaining, to the ln of the original current, and the original current is this current, or current naught is this current that is when time is 0. Okay, and having that, we can be able to say ln of E is going to be T of ln of RC. So taking this on the other side and rearranging this equation, we are going to have C as T over R into ln of I naught minus ln I, after rearranging the equation that we were having there. This is exactly what we are going to have at that given point. So meaning that we need to substitute, time is 100 seconds, and current is 0.8, and I naught is 2.4. Remembering that 2.4 is basically milliamperes. Most of the time, students are going to forget that area, that these values that are given here, and they end up using 2.4 as amperes. You have to be very keen as if your life depends on this. And then if you substitute that, you are going to ultimately work this out. Our times 100, our resistance is 5.1 kilo, and don't forget this is K, so you're going to multiply this value by 1000. If you are going to forget that, don't blame anybody, don't blame anybody, don't blame your teacher, don't blame Prof. Lan. Already Prof. Lan has told you that the alligator is sick. You have to multiply this by 1000. You have to multiply values that you have on this axis by 10 raised power negative 3, so that you are going to maximize on your mark. So if you work it out, you are going to get your answer as 0.0178, which is approximately giving you a value which is 0.02 farads, because if you round off this to the correct number of decimal places, you're gonna get this. And we are supposed to calculate the charge in the capacitor, and the charge stored in the capacitor is going to be equals to capacitance times the voltage, which means when it's fully charged, what is the current? The current is this when it's fully charged, and also the resistance is 5.1. Then we can be able to work out the voltage when it's fully charged is 12.24 volts. Then once you have gotten that, you can now come here and employ this formula by capacitance times voltage, and then this is going to be 0.0178 times 12.4, because already we had gotten the capacitance from the previous question. That's why we are doing that. And well, if you work out, you are going to get 0.22 coulombs, and that is going to be the charge when fully charged. And you are supposed to work out the energy stored, and energy stored is going to be given by the formula I have QV. So energy stored is the amount of charge times the voltage, and that's going to be 1.3 joules of energy. Question number 3, we are told a train, the model railway is powered. A train on a model railway is powered by contact with the rails, and the train sometimes loses contact with the rails, and the diagram shows the circuit that can maintain and mitigate that loss of contact. And the point here is, when it loses contact, this switch is going to be open, and when it's opened, the power supply cannot come from the battery, but it's going to be supplied by the capacitor, because capacitor stores charge, and it can be able to release that charge within a very short period of time, and hence giving a lot of power. Then we are supposed to explain how the circuit maintains the power to the electronics. So we understand when the toy car is in contact with the rail, what's going to happen is that the train, the battery is going to supply power to the electronic controller. When it's off the train, when it loses contact, the switch opens, and then you're going to realize that the capacitor is going to discharge at that given point. When the capacitor is discharging, is going to be supplying power into this electronic controller. That's basically how this circuit is going to work. The next part here, we are told that calculate the time taken for the potential difference across the capacitor to decrease to 4.0, decrease to 4.0, but V naught is 12 volts. So how long does it take to decrease to 4.0? And also something that you need to check is that we are given the resistance here and we are given the capacitance, so which means we are going to apply this particular formula. Voltage is remaining is equal to the original voltage times the E raised to power over raised to the exponent of t negative t over RC. Yeah, so we have the resistance here is 470, capacitance is 47 millifarads, so meaning this is going to be multiplied to 10 raised to power negative 3. And then if you rearrange this formula, guys, you are going to have time to be RC into ln V naught minus L of V. Then if you substitute the resistance and the capacitance, which is provided here, and the voltage, original voltage was 12 minus the voltage that they are asking at this given point, the duration time that is going to be taken is going to be approximately 24 seconds. Yeah, so they are also asking to graph and sketch how the current is going to behave 0 to 20 seconds. So up to it switched closed for 20 seconds. If it's closed for 20 seconds, current is going to be constant throughout, but the moment it's open, then it's going to discharge in that period of time. Well, in this paper, you'll also be asked question which tests whether you know how to work out question to do to multiple choices, and usually this is the area that you can easily get marks. We're told that the potential difference across a capacitor or capacitance C, the charge stored is Q. So we have voltage V and C, charge stored is CV, right? Then the capacitor is replaced with two capacitors, each of capacitance to C. So meaning that you have to get the total capacitance in this circuit, which means that total capacitance is going to be the sum of the two capacitors. When capacitors are connected in parallel, you are going to add the two to get the total capacitance. And then for you to work out the total charge is going to be C capacitance, which is 4 farads, yeah, in this case 4 farads times the voltage, which is V, and that's going to translate to 4 CV. Yeah, you can see now this becomes 4 C times V becomes 4 CV, but from this part here, charge is equals to CV. CV can be replaced with Q, and then that's why our answer should be denoted as D. The correct answer for that case becomes D. The student investigating capacitor said the circuit as shown below. Yeah, so those guys who asked me to do Excel, capacitance, charge, I believe now you are enjoying this. Give a reason why the circuit did not operate as intended. The student planned to use the circuit to measure potential difference across the capacitor, but you see, as it was charged. So when it's being charged, this should be connected here, right? So as it's being charged, this is disconnected, yeah. So which means when it's charging, the voltage is not across C, so it will not be able to measure. So that's why it failed, right? And when it's discharging, yeah, when it's discharging, when this is connected on the other end here, when this is connected here, it means the resistor will not be in connection. So ideally, the student could have connected the resistor at this point and then connect the voltmeter somewhere here in order for it to function as intended. So basically, that's what the student could have done. Then the student moves the switch to position X. To position X means now it's going to be charging, right? It's going to be charging. Then the current in the circuit will be decreasing at that given point with time. Determine the resistance of the circuit when the switch was in position Y. When the switch in position Y. So at this given point, we are supposed to identify a point on the graph. As usual, identify that, read down here, you have the time, and check here, you have voltage. So the V naught is going to be this value here, which is going to be approximately 6.2. This value is 6.2, but V is remaining is going to be 5. Then we can now be able to plug that into this particular formula that we have been having here. And then we try to make R the subject, yeah, making R the subject. We shall move this on the side and then move L of V on the side. Then we shall multiply both sides by C. And if you make R the subject, I'm not teaching maths now. If you make R the subject, if you want to learn how to do this maths, again, you'll be coming for Prof Learn. I'm just joking, guys. And then, so that we can be able to make R subject, we shall have R is equals T over C into L V naught minus V. L of V, and then if we substitute, because our V naught is this value that we have here, 6.2, V is 5, time is 5 seconds. Then if you plug in, you'll get the value as 1.1 times 10 raised to the power 7 as the final answer in that case. Now determine the average current in the circuit between time is equals to 0 to time is equal to 30 seconds. So in order to work it out, we are going to work out the charge between that particular duration. So we can be able to calculate the charge using CV. So we shall calculate the charge when time is 0. So we are going to take the capacitance, which the capacitance which we were given here, which is 2.2 microfarads, times the voltage when T is 0 is 6.2. We work out the charge in that scenario, and the charge in that case is going to be 1.36 times 10 raised to the power negative 5. Again, we work out the charge when T is equals to 30 seconds. So we are going to come here and check 30 seconds here. What is the time and what is the voltage? Again, sorry, what's the voltage here? Already the voltage we can be able to say here is 1.8, and the capacitance was given, so we are going to say charge there is going to be this. Then we are going to subtract the two values so that we get the charge Q in that direction. And once you have gotten the charge Q, you can now apply the formula charge is equals to IT, current equals to charge divided by time. Once you've gotten that, guys, you are going to do it there. Once you've done that, you are going to get your value translating to what? 3.2. Yeah, 3.2 times 10 to the power negative 7, like that. Just like that, just a walk in the park. Calculate the energy dissipated. How do we go about energy dissipated by the current between this particular duration? So we are going to work it the same way we've worked out the previous question. We shall do the energy dissipated when time is 0 and also energy dissipated when time is 30 seconds. Then we subtract the two. But how do you get energy? Energy is a half QV. Yeah, so basically that's what you gonna do in that particular part. And if you are new to ProPlan YouTube channel, consider subscribing so that anytime I'm going to do further tutorials, you'll be notified. Well, still in capacitance and how to do calculations to do with this kind of question, we told a student plan to use a capacitor in a timing circuit. The capacitor was connected in series with a resistor to determine the capacitance of the capacitor. The capacitor was charged while measuring the current in the circuit, and the graph was plotted as shown there. The value marked on the capacitor was 22 microfarads. Show that this value is correct, and the resistance of the resistor was this. So, in order to work out this question, what we did, or what I did here, is just use the formula. I use this formula here. I, current that is remaining when it's discharging, is equals to the I naught E of negative T over RC. All right. So if you introduce logarithm here, you are going to have this. But if you rearrange this equation into the form y is equals to mx plus c, you realize that our x is the time, which is on the x-axis, yeah, which is on the x-axis, and also our our y-axis, we are going to have ln of current. So ln of current is on the y-axis. So which means that this section that we have at this point here, negative 1 over RC, is going to represent the gradient of this graph. So you are expected as a candidate to ensure that you are going to work out the gradient. So meaning that if we are saying that this part is equal to the gradient, then we're going to say gradient of this graph that we are having at this point of time here is going to be equivalent to negative 1 over RC. Since we are trying to work out value the capacitance, because we are supposed to the value is must show that the value is correct. We are supposed to show that the value of the capacitance is correct. So meaning we are supposed to calculate the capacitance in this particular question in order to show that is that it's 22 microfarads. So meaning we need to make C the subject here by dividing the gradient and multiplying C both sides, and then our equation now becomes the capacitance is going to be 1 over negative capacitance is going to be negative 1 over gradient times R. R is given here. So the work that you have as a candidate here is to ensure that you find the gradient of this straight line that we are having here. When I worked out the gradient, I got my gradient to be negative, because the line is sloping that way. It's going to be negative 0.1875. So once you have your gradient with you, you can be able to go ahead and then plug it in here. You plug in the gradient and then try to work it out. You're gonna get negative 1 over negative 0.1875 times the resistance, which is 240 kilo. Most students missed this because they never remembered the kilo that was on the resistance. Then if you work it out, you're gonna get it 2.2 times 10 to the power negative 5. Then if you convert this to microfarads, you're gonna get is 22 microfarads, which is correct and which we have shown at this point. The capacitor was used in the circuit to time a collision between two identical metal spheres, and at that given point the student was supposed to calculate this particular height after collision. Yeah, so you need to remember calculate the maximum speed. Sorry, you're supposed to calculate the maximum speed, and then we're going to use potential energy and kinetic energy equation, just combining them. So the height that was given here was 1.1 centimeters. So we were supposed to find the gravitational potential energy at that given point, and if you work it out, you are going to get the gravitational potential energy being 3.0 times 10 to the power -3. Also, we're going to say that gravitational potential energy is going to be converted to kinetic energy, right? So which means that we are going to say Ke is equals to 1/2 mv squared, and when you equate with that, you are going to make V the subject of the formula. If you work it out, you are going to get 0.46. That's the approach you're gonna use it there. Calculate the time for which the sphere were in contact. Then we're going to use Newton's second law of motion. Then since we have gotten the velocity here, we can be able to work out the momentum and then use the concept of change in momentum over t is the force, right? So meaning that before that guys, we are going to work out the time. We are going to use this formula here, which is V is equals to V naught E over negative T over C. So meaning if you work out the time, making time the subject of the formula, this is the formula we shall use. But resistance, it was provided, resistance was 49 ohms. 49 ohms, well given here. 49 ohms, that's the resistance. Yeah, 49 ohms. I need to ensure that the camera is clear and brisk, clear, very clear. Yeah, we are given the resistance here is 49. We have given the capacitance. We are given the potential difference, yeah, for this particular duration. So it was up to 6.18 to 5.43. So those are the values that we're going to input here in order to work it out, and you're going to get the time is 1.4. Okay. Deduce whether the statement is correct. Which statement was this were we being asked here? The student stated that the average force acting on B cannot be more than the weight of A. But first, we need to know what's the weight of A. Weight is mg, and the weight is going to be 0.275 newtons. But for you to work out the force during collision, you need to know the momentum. Momentum is mass times velocity. So the momentum is 0.012964 newton seconds. But the duration of collision is this. Yeah, right? Duration of collision is this. So we can be able to calculate the force. You can be able to calculate the force using change in momentum over time formula. Change in momentum over time formula, right? Then if you apply it, you are going to get the force is equivalent to 92.6. So 92.6 and 0.275 newtons. Surely, do they even compare? How can a level student make such a conclusion? So we can be able to say the suggestion is very wrong because that student might have not attended Prof. Lang YouTube channel. So meaning that the suggestion is wrong because the force is much greater than the weight. So the student made a very, very wrong suggestion. Yeah, so moving to this question, we told the capacitor of capacitance C is charged to the potential voltage V naught, and the capacitor is then discharged. So meaning when you hear that, these are the kind of formula that are coming in. Which of the following is the time constant for this circuit? Time constant, something that you need to remember. Time constant is denoted by tau, and the time constant is usually RC. Time constant is usually RC. Okay, So which means that we are going to rearrange our equation so that we can have it RC like that. Yeah, if you rearrange your equation, it's gonna become that. We usually know that ln RC is equals to ln over T is equals RC ln of V. But if you introduce a negative, you can be able to switch the values up and down. Yeah, so you can be able, you can see V and V naught is down. Usually it's V naught that is up. When you switch it, it's going to make it turn. So our RC is going to be negative T over V ln of V naught. And then that's what you're gonna get. And that's option D. D is the correct answer for that. All right, yeah, so the next part is the graph of current against time is plotted. So the graph of which of the following is capacitance? Basically this is ln of current over against time is plotted. So this is the equation. Which part, what shows capacitance? So meaning this part that we are having here, negative 1 over RC, is going to be the gradient of that graph. So gradient is going to be this. But since we are finding capacitance, we multiply by R and divide the gradient both sides. We are going to have this concept here. So basically this multiple choice question they were testing this concept that we have already done and used in the other previous question here. All right, so moving on to the next part. We are done with that. Yeah, so in the event you are asked also which expression shows charge stored, you need to remember that charge stored is equals to Q equals to CV. Charge stored is equals to CV, current capacitance times the voltage, and that is exactly what we have here. And there is an introduction of microfarad here, so don't forget that. Which expression gives the energy stored? Energy stored is equals to a half VQ, or QV, a half QV. That's the formula, and then you get to check which one is the best one for that. All right, so okay, yeah, so that is that. We are told that a battery of EMF V is connected to the capacitor as shown here, and the capacitor is initially charged. Work is done by the battery to transfer charge Q from one plate of the capacitor to the other plate. The final potential difference across the capacitor is a V. Then you are supposed, which will give the work done by the battery and the energy stored. So something that you need to remember, energy stored is a half QV. Work done is equals to QV. Charge stored times the voltage is the work done by the battery. But energy stored is a half QV. Don't confuse that. So if you do that, you're gonna get your answer being equivalent to X. Yeah, so there's another question here. We are supposed to work out the work done by the trap. Yeah, so basically you are going to make use of that approach. Work done is equals to force times the distance moved, and then the distance moved here we are going to use r theta, the radius, and the radius is going to be this in meters, and in that case r is this, and the angle is this value that we were given here. We were told that it moved angle of 90 degrees, so that is pi over 2, right? So we can be able now to multiply the force that, but the force is going to be the average force, average. So we are going to do the average of that 2.6 plus 9.6 divided by 2. Then we multiply by the distance. We're going to get the work done as 0.47. The transformer T consists 2 coils. Explain how applying a PD across the input causes the capacitor to charge. So remember, when the alternating current passes through here, is going to create magnetic fields in this section, and those magnetic fields are going to be linked to the secondary coil, which is going to result to a magnetic flux linkage, which is going also, when there's a magnetic flux linkage, that's going to generate there will be an induced current. So the output coil then the varying magnetic field causes a change in the magnetic flux linkage, the secondary coil, inducing an EMF. Yeah, so we are going to have an EMF here through electromagnetic induction. So the diode that we are having here is going to act as a rectifier, so that current is going to flow in one particular direction because it was alternating. So we shall have direct current that's going to charge the capacitor here. So basically that's exactly what you are going to do. Until next time, guys, we're gonna pick from there. We shall move to the next topic. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. Mostly I'll be doing A-level physics, that is Cambridge and Edexcel physics, on Sundays. And then we shall have IGCSE, our IGCSE lessons on the Black Friday will be for the IGCSE guys, physics. And then if you are new, you are taking Cambridge, you are taking Edexcel, consider joining Proflan YouTube channel so that when I'll be uploading more tutorials, you'll be notified. For A-level guys, Sundays, we have a date with you. And for the IGCSE guys, on Friday, we have a date with you guys. See you in the next tutorial.